Welcome to Calbeckistan, place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about exponents. This is our first in our series about exponents, so if exponents are just kind of scary to you, this is a great place to start. We're going to be discussing the whole concept of what a negative exponent is, and also what happens when you take something to the 0 power. Let's get started. All right, as we begin our discussion on exponents, we need to sort of remember what the heck an exponent actually is. All right, so an exponent, that pen doesn't work. You did. All right, so I know that my pen works, so we'll get back into it. What is actually an exponent? What an exponent is there's a little number up here. Okay, if you ever see a little number that's above and to the right of a number, that's an exponent. There are other little numbers you'll see, they are not exponents. For example, I could have, a lot of times you'll see like little numbers down here with variables. Those are called subscripts and they're completely different. That's not what we're talking about today. What we're talking about today are these guys up here. We're talking about exponents. And what exponents do is they take something and they multiply it over and over and over again. So for example, with 3, if I put a little 2 here, what that means, 3, and this we say 3 to the second power, or 3 squared, what that means is 3 times itself. So there's 2 3's that are multiplied together. That's what this means. 2 3's multiplied together. Sometimes you'll write it out. It's never a bad idea to show your work here. So I have 3 times 3. That's what that means. Okay, and that's all exponent is. It's a shortcut for multiplying the same thing again and again. And so if you understand multiplication, you actually understand exponents already. And if we can kind of make a little chart here, and what we're going to do is see if we can find some patterns that emerge as we understand what's going on here. So 3 times 3 equals 9. All right, that's great. Cool. Let's look and see what happens if you get bigger exponents. You can also have 3 to the 3rd power. Sometimes we call that 3 cubed. And what that means is we have 3 times itself 3 times. Okay, there's 3 multiplied 3 times. That's what that means. Okay, and that number, if you multiply it out, 3 times 3 is 9, times 3 again is actually 27. But the question that we were going to ask in our video today is what happens when I have 0 or negative exponents. So what I'm going to do is I'm going to make a little table here. We've got 3 and then 2, and as I go down this table, I'm going to decrease the exponent by 1, and we're going to see what happens. So I can also do 3 to the 1st power here. 3 to the 1st power, that would mean there's only 1 3, right? Because this means there's 2 3's, this means there's 3 of them. So if there's a 1 as an exponent, or 3 to the 1st power, that means there's only 1 3. So that's just 3. All right, cool. Which brings us to our question of the video. What the heck is 3 to the 0 power? What happens if I go down 1 more on this chart? That's really a weird question because intuitively we would say, well, there's 0 3's, right? So is that 0? 3 to the 0 power is not 0. And I'm gonna try to show you why here. What we're gonna need to do is look at a pattern that's happening with our 3's. So let's take a look at over here on this end, okay? So we got 3, 2, 1. We would assume that this is 0. Not quite. Let's look at this end, and it might give us a little bit better idea of what's going on here. See if you can right now in your own home, see if you can figure out what's going on right here. What happens if I go from 27 to 9? And I'm hoping everybody out there can see that we divided by 3. Now let's see if that pattern holds. Let's see if we do that again. 9 divided by 3 is 3. And we see the same pattern happening here. And this is a really good thing in math. If you can find patterns, you can actually discover new math without your teacher needing to tell you what's going on. So let's see what happens if we go 1 farther down. What happens if I divide 3 by 3 again? 3 divided by 3 is actually 1. Okay? And That's the really interesting result here. Anything, or 3 to the 0 power, anything is 1. Okay, and you can do this exact same thing with any number that you want. We can try it with other numbers if you want to verify. We could try it with 2's. You could do 2 to the 3rd power, that's 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. And we are dividing by 2 each time as we go down here. So if I take 2 and divide it by 2, I get 1. Okay, so the really interesting result here is that I'm not actually getting 0. Something to the 0 power is equal to 1. I want you to make sure you have that in your notes if you're taking notes today. Anything to the 0 power is 1. Now, if we know that, that actually allows us to continue our pattern even further. What happens when I go into the negatives? What happens if I have a negative exponent? So 3 to the negative 1 power, what the heck would that equal? Well, let's follow our pattern. 1 divided by 3, that's just 1/3. Okay, remember, fractions, don't be afraid of them, they're division problems. So try not to get all scared if you're seeing a fraction show up, because it's just a division problem. It's 1 divided by 3. This is kind of a really interesting result. You would think, based on your intuition, a lot of people think that negative exponents would give you a negative number, but they don't. Negative numbers give you division problems. And if you think about what's going on here, that makes sense. Because when I have positive numbers, I've been multiplying the same number again and again. Now, negatives are essentially the opposites of positives. Some teachers talk about the word opposite and negative as the same thing. So what I really want is the opposite of multiplying a number by itself again and again. And it totally makes sense if you think about it that way, because the opposite of multiplying a number by itself would be to divide that number by itself. And we see here that same thing. I've divided by 3 once. That's what this says. Okay? I'm just going to write in here 1/3. Keep our pattern continuing. So let's see what happens if I go down 1 more. Let's see what happens when I do 3 to the negative 2 power. Now this one you type in your calculator gives you a really weird result. It gives you 0.1 repeating, and that seems strange. But let's see if we can figure out why. That means we need to divide 1/3 by 3. Now, you can divide fractions pretty easily. Don't be scared. This is something they teach you in 4th grade. It can't be that hard, okay? So I have 1/3, and I'm going to divide that by 3, put that over 1. So I have 2 fractions here. And you remember how to divide fractions? All you need to do is multiply by the reciprocal. Or some of your teachers will teach you copy, dot, flop. And that's a great way to remember it. You copy the first one, you change this to a dot, and you flop the second fraction, which is another name for the reciprocal. So that's 1/3, and we multiply fractions, that's pretty easy, it's just straight across. 1 times 1 is 1, 3 times 3 is 9, so I'm actually left here with 1/9. Now here's the cool part where the pattern really becomes interesting. What's the relationship between 9 and 3? Well, it's just 3 times 3. So this pattern is actually 1/3 times 3, which is super cool because negative 2 is 1/3 times 3, positive 2 is 3 times 3. It's exactly the same thing. We can follow this pattern and a little bit farther, and we can see what happens with 3 to the negative 3rd power, and we could see here that the same thing would happen. It's got to be 1/3 times 3 times 3, or 1/27. So when you're looking at your calculator and you're saying, where the heck did these decimals come from? The place that they come from is that you're dividing that number again and again, rather than multiplying that number again and again. So positives and negatives are opposites. Positive exponents and negative exponents are also opposites. I think that's a really interesting result, and that's your lesson for today. Hope you guys stay tuned. Next video, we're gonna take a look at what happens when I throw some variables in here, but you're gonna find that every single thing is the same with variables as they are with numbers.